Hello everyone, I am Dr. Fawzul Atiq. I am giving some series of lecture for the course Probability and Statistics. So up to now, we discussed the probability of that random variable, which we have discussed only one, like single random variable, right? So in this unit of this course, we will be discussing that where we will handle two or more number of random variable at a time, correct? So we'll call them as joint probability distribution. So let us recall what is a random variable. A random variable x is simply a function from the sample space S to the set of real numbers. That is x maps S to R. Like how you can relate, like you had the for sample space, and for each outcome you have given a number, right? You have given a real number, that is the number you have taken, the random variable takes the value. Like if I have rolling of two dice, then for each event we have given some real number, that x equal to 2, that is some events are there, x equal to 3, some events are there, right? That means x equal to 2 means what, where both the dice are having the face 1 1, both the cases it is. X equal to 3 means what, it was like first two outcomes involved in that case, right? That means one roll, one die it will have one face 1 and another die it will have face 2, and the other outcome is the first die it will have 2 face 2 and the other die it will have face 1. In this way all outcomes we have given some real number, that is a random variable. We have already discussed in this one, right? And then this example we just discussed. Now we can have function of two or more number of random of the sample space. So in this case, suppose it is two random variable you have taken, x and y, right? So x and y are two different random variable we have, and then we can involve these two random variable for a single sample space, and we can find its probability for this jointly for this kind of random variable. For instance, let x be the sum as the above experiment, that rolling of two dice, and the another random variable let us define as that y, which is the value of the first die minus the second die, right? The value of the face of the first die minus the value of the face of the second die. So we have two random variable, and then we can deal with these two random variable together for a such an event, for a single event. So thus we can make the sense of a pair of random variable, and we can talk about its joint distribution. So probability also will find jointly, distribution also jointly, and thus we can talk about the probability. That means P of x less or equal to A and P of y less or equal to A. It means that both the events are happening at a time, right? So basically you can also say this is basically as P of x less or equal to A intersection P of y less or equal to B. So both the events are happening together in the case of a single event, and we want to find its probability, right? Easy. And therefore we can have the concept of joint cumulative probability distribution function. Now in case of a single random variable, we had our cumulative distribution function. What was that? We said that now f of a is equal to what? P of x less or equal to a. This is for single random variable. Now what will happen for joint cumulative probability distribution function? So the joint cumulative probability distribution function of the random variables x and y is defined by f of ab equal to p of x less or equal to a comma y less or equal to b. Right? So f of ab is equal to p of x less or equal to a comma y less or equal to b. So basically this both the events are happening together, intersection of these two events. And once we have this joint cumulative probability distribution function, we can extract that individual probability distribution. And in this case, we call them as marginal distribution function, right? So now looking, if you look only at x, then the distribution function of x is what? That means our, whatever we know from the earlier thing, that distribution function of the random variable x, fx of a, it is p of x less or equal to a. And how we can get it from the joint? it is the P of x less or equal to A and y is less than infinity. That means y probability we have calculated for the whole sample space. So minus infinity to infinity, that y probability. That means this, it is the whole sample space, right? And intersection with x less or equal to A. So we can easily write this two event. But according to our joint probability sense, this is actually P of A comma infinity, right? So this one we called it as marginal distribution function of x, right? So at the same way, how we can get the marginal distribution function of y? Yes, so in this case, P of x should be less than infinity and y should be less or equal to b. Maybe I should say it is b. And this value is what? P of infinity comma b. This will gives you the marginal distribution function of y. I hope it is clear. Okay. Now, yes, this one we have already discussed. Fx and Fy are referred to the marginal distribution of x and y. Now, all joint probability statement about x and y can be answered by their joint distribution. Like just for as an example, suppose we want to calculate the probability of this event. Suppose x and y are two random variables whose joint distribution we have. Then I want to calculate this probability p of x greater than a, comma y greater than b. How we can calculate? Okay, so what we'll do, one, can I write 1 minus p of x greater than a, comma y greater than b. This is an event and I have to take its complement, right? But what we said, this event is basically the intersection. So 1 minus p of, can I write that x greater than a intersection x greater than b and whole complement you have, and this probability. But a intersection b whole complement. If I apply the De Morgan's law, what will happen? It will become 1 minus p of x greater than a whole complement union x greater than b whole complement, right? By De Morgan's law. But x less or equal to a whole complement means what? P of x must be less or equal to a union x less or equal to b. Two event we have. Now probability of A union B, right? We know by the principle of inclusion exclusion property, we can say that it is 1 minus that P of x less or equal to A plus P of x less or equal to B minus their intersection P of x less or equal to A intersection x less or equal to B. Done? So we can say this, and therefore this one is what? Minus P of x less or equal to A is what? It is the marginal distribution. So P of x A minus P of yb, then minus and minus will become plus P of x less or equal to A, y less or equal to B. What is that value? It is f of the joint cumulative distribution function, right? So we can say this value. So once we have the joint distribution, we can able to get this kind of probability. I hope it is clear. So and the similarly, we can have the this one we have already proved. Similarly, we can able to find the probability of this kind of event, that a1 less than x less or equal to a2, comma b1 less than y less or equal to b2. And if we find that in the same way, we can get f of a2 b2 minus f of a1 b2 minus f of a2 b1 plus f of a1 b1. I'm not simplifying it. Just you should see that, okay, this is happening. If we know the distribution function, we can able to get the probability. Okay. Now, then if I have that x and y are discrete type random variable, then where x taking on one of the values xi, where I is greater or equal to 1, and y takes the values yj, where j greater or equal to 1, then the joint probability mass function we can define. Whereas we know the probability mass function of x is what? The p of x is equal to x, right? It is equal to small p, or probability of the event x, particular value x. So then we can define the joint probability mass function. The same way, the joint probability mass function of x and y is defined by pxy, which is probability of x is equal to x, comma y equal to y. Clear? Okay. So we can say in the same way, once we have the joint probability mass function, can't we get the marginal probability mass function from that? How to get the marginal probability mass function? So x is equal to x is the union of mutually exclusive event. Why? Because y equal to yj. So can I write that like what is this event? Union over j, y equal to yj. So for all y value, yj value, union over j is what? It is the whole sample space. Yes or no? Because random variable takes the value, the random variable y takes the value y1, y2, y3 up to infinity. Suppose. Then union of their event is what? It is the whole sample space. So therefore I can write this one. Now x is equal to x is a particular event, right? Capital X is equal to x is a particular event. X takes this value. Now this event intersection, if I do the whole sample space, this is what value? This is again x is equal to x only, na? Because x is the sample space. And therefore I can write the other way. If I write, or maybe x is equal to x, I can write it is union of over j, y equal to yj. It is y equal to yj. And these are all mutually exclusive, y equal to yj and all. And therefore, this is an event which I can write by the property of that x is equal to x intersection y equal to yj. This is the event x is equal to x. Now this line says that the event x is equal to x is the union of mutually exclusive event x is equal to x comma y equal to yj. Right? So this is this event. And then how to get the probability of it? So therefore the probability of this part is p of x is equal to x, which is the marginal probability mass function of x. So we denote it by p of small p of x is equal to small p of x, which is x is equal to x. And that one I can write it as probability of union of this fact, right? Probability of union of this fact. But these are all mutually exclusive event. So therefore I can write it as summation over j p of x is equal to x, comma y equal to yj. And this is what? Summation over j p of x, comma yj. What does it mean? That p of x is equal to x, the marginal probability mass function of x, it is that means you have to do sum over all yj value and keep x as fixed. That will give you the margin. Right? In the same way, if I ask you that, yeah, this is the calculation we have already done. In the same way, what is the marginal probability mass function of y? So marginal probability mass function of y will be p of y is equal to y. It is summation over I p of, like here, y will be fixed, but you have to do sum over xi, right? So xi and that is y. This will be the marginal probability mass function of y. I hope it is clear. Okay. Now let me move to the, yeah, this part we have already discussed. Now let us solve one example. Suppose that 3 balls are randomly selected from an urn containing 3 red and 4 white and 5 blue balls. Right? The urn contains 3 red balls, the urn contains 3 red balls, 4 white balls, and 5 blue balls. And you have selected 3 balls from this urn. So how many ways you can do? So there are 5 plus 4, 9 plus 6, 12 number of balls. You have selected 3 number of balls. How many ways you can do? 12 C3 ways. Okay. Keep this in your mind. Now next is, if we let x and y denote respectively the number of red balls and white ball chosen. So x denote the number of red balls and y denote the number of white balls chosen among these 3 balls. So you have to calculate the joint probability mass function of x and y. So you have three balls. You have selected. X denote the number of red ball from this three ball, and Y denote the number of, like, among these three ball, how many number of white ball you have chosen. That Y counts. So X and Y both are random variable. Now can you think of it that X will take which value? Random variable X will take which value? You have three red balls and three red balls you have selected. So X can be anything. X can take the value 0. So none of the ball is red, or one ball is red out of these three, two ball is red, or all three balls is red. Possible? Similarly, the random variable Y will take which value? Because Y counts the number of white ball. But you have selected three balls. So number of white ball can be 0, number of white ball can be 1, can be 2, or can be 3. Because you have selected only three balls. So random variable X and Y take these values. Now what we have to find? We have to find the joint probability mass function of X and Y. So therefore we have to find P of Ij, which basically gives you X is equal to I, comma Y equal to J. For which value? For all Ij values lies between 0 to 3. So how many such values we have? So for X4 and Y4, so therefore 4 4s are 16 number of these values we have to calculate. Right? So let us calculate one by one. Now, therefore, what is this P of 0 0 value? P of 0 0 means probability of X is equal to 0, comma Y equal to 0. Now, how to calculate P of X equal to 0, Y equal to 0? So, among these three ball, there is X number of 0 number of red ball and 0 number of white ball. What does it mean? All these three balls are blue balls, right? So how many total number of blue balls you have? 5 number of blue balls you have. How many ways you can select these three balls from these 5 blue balls? 5C3 ways. So this probability will be 5C3 divided by the total number of choice. So 3 balls you have selected among 12 balls divided by 12C3. I hope you understand. So P of 0 0 value is this one, and if you just simplify it, you will get this value is 10 divided by 220. Clear? Similarly, P of suppose 1 comma 0. What is this probability? It is P of X is equal to 1 and Y equal to 0. Now X is equal to 1 means what? How many, one number of red ball among these three ball, you have chosen one red ball and you have chosen 0 number of uh, white ball. Therefore, the rest of the two ball is what? They are blue ball. So how many ways this is possible? So 3C1 ways you can choose the red ball, 3C1, and the rest of the two balls are blue balls. So but how many blue balls? 5 blue balls you have. So it is 5C2. I hope you understand. There are 3 red balls you have. You have chosen one red ball among these 3. So 3C1 ways you can do. And you have 2 more balls are left. But these 2 ball must be the blue ball because there is 0 number of white ball. So how many ways you can select this 2 blue ball from 5 blue ball? 5C2. So 3C1 into 5C2 divided by total number of choices 12C3. And again, if you just simplify, you'll be getting this value is 30 divided by 220. Correct? So in this way, you can calculate all the value P of 0, 1, P of 2, 0, P of 0, 2. Correct? Maybe I'll do one more one. P of 0, 2. How we will find? It means P of X is equal to 0 and Y equal to 2. How to get this probability? So it means among these three ball, there is 0 number of red ball and 2 number of white ball. That means one ball must be a blue ball. So how many ways you can do? So it is white balls are 2, right? So 4C2 ways you can select. Into you have 5 blue balls, among this one would be a blue ball, so 5C1 and divided by 12C3. And again, if you just simplify it, it will be 30 by 220. This probability is also 30 by 220. In this way, you can find the probability of all these 16 probability mass functions. Now, one observation I wanted to tell you, that what is this probability? Suppose P of 1 comma 3. What is this probability? It means that among these three balls, one ball is red and three balls is white. Is it possible? So whenever it is not possible, right? So this probability must be 0. That three among the three ball, how can be one ball is red and three balls is white? Not at all possible, right? Similarly, p of small p of maybe 2 comma 2. What is this value? So among the three balls which we have selected, two balls are red and two balls are white. Is it possible? Not at all possible. This probability is also 0. So whenever we see that this sum is more than 3, the probability will be always 0. Correct? So many of the probability we don't have to calculate. So this will gives you the joint probability mass function of x and y. Now the point is to write down all of them, like I have calculated all the values. You just see, all of you verify all the things and then see that whether your answer is correct or not. And whenever the values are more than the number 3, the sum of these, like p of 2 2, this must be 0, p of 1 3, this must be 0, 3 1, this must be 0, all this will be so on are 0 0 0, right? Other values are these, so you can just verify your answer with this. But to write down the probability mass function in this way is not looking good, or it's not, it is difficult to manage, right? So what we can do in that case, we will write them in a tabular form, right? How we can write them? So we will write them in a tabular form. How? So we make a table, and then you make some of your cell, and then for each uh, random variable 0 1 2 3 you have. So I'll make 4 number of rows and 4 number of columns. Similarly here also 4 number of rows, 4 number of columns. And what we'll do, that column will say, we'll calculate that y equal to j, and row will calculate y equal to j, and column will say x is equal to I. Right? So y takes which value? 0, 1, 2, and 3. And this will take value 0, 1, 2, 3. Right? So probability of x is equal to 0 and y equal to 0, x is equal to 0 and uh, y equal to 0 is what? We have already calculated. X is equal to 0 and y equal to 0 was 10 by 220. So we'll write this 10 by 220. Next, what we have calculated? P of 1 0 we have calculated, right? So x is equal to 1 and y equal to 0. X is equal to 1 is this one and y equal to 0. Therefore, this value we have calculated as 30 by 220. Similarly, we have calculated P of 0 2. So x is equal to 0 and y equal to 2, and that value was 30 by 220 again. So this value is again 30 by 220. Right? So in this way we can fill the whole table. We have already calculated, so I'll write down that 4 by 220, and this value 0 3 is 84 by 220, and this value is 30 by this 60 by 220. And in this way, all the value if you do, we can fill this up 18 by 220. And what will the probability of p of 1 comma 3? This is sum is more than 3, so this value must be 0. We have already discussed. And this was 15 by 220. This is 12 by 220. And this value must be 0. This value must be 0. 3 comma 0 is, it is 1 by 220. But 3 1, this value must be 0. 3 2, this value must be 0. This value must be 0. Right? So in this way, we can immediately write the joint probability mass function of x and y. So there are lengthy calculations, may be lengthy. The problem is not. Right? And how can we calculate the probability mass function of the random variable x? So then you have to do that x is equal to 0, marginal probability mass function, right? So take sum over y and x equal to 0 value, right? So if you do this sum, that means this sum, this. If you take this sum, this will give you the probability of x is equal to 0, this value. And if you do this sum, if you do this sum, that means what, x is equal to 0 and y summation over y, right? And this value will be giving you that 84 divided by 220. So in this column, we can have x is equal to I. That means the marginal probability mass function you get if you do the column wise this. So the next one, what will be there? It is 108 divided by 220. Again, if you do this row sum, it is 27 divided by 220. I can see that. And this one, if I do the sum, it is 1 by 220. So all of them gives you the marginal probability mass function of x. At the same way, we can able to find the marginal probability mass function of y. So this, if you do the column sum, P of y equal to j, this just if you do the sum, it is 56 by 220. Then it is 112 divided by 220. This is 48 by 220. This is 4 by 220. Done. And we know that if you just add up all the probability mass function for a single variable, the sum should be 1. So you can see that if you just do the column sum of this one, you should be able to get 1. This value is 1. And again, if you do the row sum, this value, again, you should be able to get this value is 1. Right? So you can get this value to be 1. That just for verification purpose, your calculation is correct or not. You can just add up and you should be able to get this value is 1. You'll get the answer. Right? Let us give one more example. Yes, this problem we have already discussed. This one we have done. And how to get the marginal probability mass function of y. That means sum over this x. Probability mass function of x is sum over y. And we get the probability mass function this. And this sum is actually the summation of x is equal to xi and y equal to yj both. That will give you the third one. That means summation of p of I comma j. So this summation is actually p of I comma j. Summation over I and summation over j. This should be 1. That is the probability sum, total sum. I hope it is easy. Now I have one more example. Let us solve this problem. Suppose that 3 balls are chosen without replacement from an urn consisting of 5 white and 8 red balls. Right? So you have 5 white ball and 8 red ball. So there are 5 plus 8, 30 number of balls. But you have chosen 3 balls without replacement from this urn. And here xi equal to 1, here xi equal to 1 if ith ball is selected is white. That means x1 is equal to 1 if the first ball is white. Otherwise it is 0. Right? So x1 takes which value? X1 will take only two value, 0 and 1. So whenever in the first step you will get the value is white, then you will say x1 is 1. Otherwise x1 is 0. Similarly, x2 is also having the two value, which is 0 and 1. But in case of x2, if in the second ball is white, correct? So therefore, this random variable x1 and x2 will take these two values, 0 and 1 and 0 and 1. Now you have to find the joint probability mass function of x1 and x2. So x1 and x2 takes the value 0 and 1. Then what are the possible pairs? 0, 0. That means both the first and second ball both are red. So that means x1 is 0 means what? That means the first ball must not be white. That means it is 0. It is red. And y equal to 0 means what? The second ball is also not white. That means it is red. So therefore 0, 0 means both the first and second balls are red. Similarly, 0, 1 means the first ball is red, second ball is white. 1, 0 means that, and 1, 1 means both the balls are white. Now we can do the probability of each of them. So what is that P of 0, 0? It means probability of x is equal to 0 and x1 equal to 0 and x2 is also 0. Now probability of x1 equal to 0 and x2 0 means what? The first ball without replacement, the value is, it is a red ball, right? So 8 by 13 ways it is possible. into the second ball is also a red ball, but without replacement. That means there are 7 balls you have. So 7 divided by 7 red balls you have and divided by 12. So you'll get this value is 56 divided by 13 into 12, it is 156. Similarly, P of 0, 1 we can calculate. That means the first ball is red and the second ball is white. How to get this value? First ball is red, second ball is white. So P of first ball is red, how many ways? 13 divided by 8 divided by 13 ways you can do. First ball is red and second ball is white means what? So there are how many white balls you have? 5 white balls. And how many balls are left? 12. So it is 5 by 12. So it is 40 by 156. I hope you understand. In this way, we can calculate the other values and we can also make it in the tabular form, right? If you just do it, P of 10 is this, then P of 10 is what, which value I have already calculated. It was again 40 by 156 and P of 11 is what? It should be that 5 by 13 into 4 by 12, it is 20 by 156. So we can write all of them in a tabular form and we can write the table in this. And if we do the sum, this sum, we'll be getting this is the marginal probability mass function of X. This is the marginal probability mass function of Y if we do that. Now, till now we have discussed only the discrete type joint probability distribution, right? Now, this can be extended for continuous type joint probability distribution. Now, in case of a continuous type, we will not have probability mass function, but we'll have probability density function, that fxy, and that can calculate the probability, right? And then we can calculate the probability in this way. That marginal probability also we can do, right? So fxy is the joint probability density function. Then the marginal probability means what? X can be fixed and take sum over y, but it is a continuous function, continuous random variable. So take integration over y. So minus infinity to infinity fxy dy. Similarly, fy is what? So take y as fixed and do integration over x minus infinity to infinity. So integration over x, previous one is integration over y. So at the same way, we can able to calculate for at any region C over belong to R square probability of the joint probability xy belong to C is the double integral over C fxy dx dy, because it is the joint one, so we have to do double integral. X belong to A and y belongs to B. This probability is integration over A, integration over B, fxy and dy first. So you are doing over B first, no? So dy should be first and after that x. You can calculate the probability in this way. Now we can do one, and similarly joint distribution function also we can calculate. So f of p less or equal to a comma y less or equal to b, so minus infinity to a and y value is minus infinity to b. This is actually x integration, this is y integration. So dy and dx. You can find the joint probability distribution. Now if we just wanted to solve one example, we can easily do that. How to solve this example? P of x greater than 1, y less than 1. So this probability is, that means x value is from 1 to infinity, right? So x is equal to 1 to infinity. And y value is minus infinity to 1. So y value is minus infinity to 1. And then fxy dy dx, right? So fxy means 2 e power minus x minus 2y into dy we are doing inside 1 into dx. But this integration we can just do it because e to the power that thing we can separate it out. So we can make it at x is equal to 1 to infinity e power minus x dx and into integration minus infinity to y e to the power minus dy dy. And if you calculate this value, we can do the 2 into e power minus x by minus 1 over 1 to infinity into e power minus 2y divided by minus 2 into minus infinity to 1. And if you put the value, my e power minus infinity will gives you 0. So 2 into e power minus 1, right? So this place it will be, this 2 and this minus 2 can be cancelled out. So e power minus 1 into 1 minus of minus infinity, right? Okay, so minus infinity to 0, but minus infinity, this value, y value is from this, na? So this value is actually 0 to infinity. I was wrong, it is 0 to 1. This is 0 to 1. And if you put this limit value, e power minus 2, and this is minus, then plus e power 0 means 1. So this is e power minus 1 into 1 minus e power minus 2. This will, you will get the value like this. Similarly, we can calculate this value, and other values as well. So how we can calculate x less than 2? P of x less than 2, x less than y. Like I just wanted to show you, P of x less than y is, okay. Okay, in the next lecture, I will discuss about these problems, right? Because I need 5-10 minutes to solve it. So in the next lecture, I will complete this solution. Okay, so we'll meet in the next lecture to finish this problem. Thank you very much.